Hi everyone, welcome back to Advent of Code Day 7 Bridge Repair. So in today's question, we are still looking for the chief historian. I think we'll find him on day 25. And we've come to this place in the forest where we have to cross a bridge, but we're not being able to cross a bridge because of some issue, and the issue is that some elephants have stolen operators from equations, and we have to find whether we can complete the equations with some operators. So they've given us this example where there are these equations, we have the result and we have the operands, and we have to put operators in between that to see if it is possible to get this result. So for example, 10 into 19 would give us 190. Similarly here there are two possibilities. I didn't know while looking at this, but they've told us here that there are two positions for two operators, which means between 81 and 40 and then 40 and 27, and there are two ways in which you can get the right answer. One of which is 81 times 40 plus 27, and the other one is 81 times 40 plus 20, whatever. These are the two possibilities. So and similarly there's one more equation, but not all of them are possible. So now we have to find which one of these are possible, and for all the ones that are possible we have to sum them up, and that will be the answer for our part 1. Okay, so let's try it. Okay, so how we are working with this is the initial bits are the same as everything, but a little bit more complex. So in the dummy input, what our pattern of the input is that we have the result. It is separated by this colon from our operands, and the operands are separated by each other with a space, and each equation is separated by a new line character. So first we are splitting it to separate equations, then each equation we are splitting it into a result and operand part. Then when we are just converting it to numbers, the result is a number and the operands are separated by a space, and they both are numbers as well. So we get our equations. Then we are checking for calibration results. Why have I named it like this? Anyway, for now, get calibration results. I should have calibrated results was the right thing, but anyway. So here we are keeping a track of the total calibrated results, which is the sum of all the ones which all the possible equations. And then in this we have multiple equations. For each of the equation we get the result and on the operands part. Now, and we are checking if it is a possible equation by using this method. I will get into that after this. And if it is possible, we are adding it. So this part is pretty simple. Now for this check if possible equation, we are actually using recursion. So how this works is we are taking the results and the operands. We are checking if, we are keeping a track of the is possible equation flag, and we are keeping a deep copy of our operands and currently tracking it as remaining operands, because we're going to take operands one by one from left to right and then perform the operation on them. So this current result, we are keeping track of the current result as well, and we are going to compare it to the final result. So we are shifting, which is like FIFO. So the first thing which gets in, that's the first thing that gets out. If you have 1 2 3 4 5, if you shift it, it becomes 2 3 4 5, and it gives you 1 as the output. So 1 gets stored here. In our case, we have 10 and 19, so here I'm keeping track of that. We have 10 and 19, so this becomes 10. Then we are checking in a while loop if the number of operands that are remaining are greater than 0, only then there is a point of doing all this. So if they are greater than 0, in our case there was 10 and 19. This is the best case and the easiest case solution, which is generally not recommended to be used. You should use the worst case so that your edge case is also included. But for this example, let's take this. So this is 10 and we have remaining operands as 19, so the length will be 1. The next operand we'll again shift it, so we'll get 19 here. The new result will be 10 into 19, which is 190. So we have the result already, but we are going to anyway, this was the best case, right? But in the worst case, we'll still need to check for the other possibilities. So we will check for the result, and we're making a new array which consists of the new result and the remaining operands. In our case, the remaining operands is nothing, so it'll just be an array with one element, which is the result. And if this returns false, then we will again, instead of multiplying it, we will add it and then check for the same thing. So now in our example of 10 and 19, it will go into the loop again. This time the result will be 190, and the operands will be an array with element 190. So it will come here, results, the current result will be 190. It will not go into this loop since the remaining operands will become like null, empty, and it will come here to the next part. Here it will check if the current result and the result are the same, then it marks it as possible equation true, and then it returns it. Otherwise, if these two are not equal and the number of operands were over, then it would return false, which is the default value. So with that, I got so confident that I didn't even check whether I'm getting the right answer. So let's check here. 3749, what was given to us? 3749 is what was given to us. So now let's check it for the actual input and hope that we have not missed any of the edge cases. Okay, so that's a huge number. Awesome, this was quite easy actually. Now let's go to part 2. Okay, so in part 2 they are telling us, initially they had told us there are only two operators, the add and multiply. Now there is actually another operator which is concatenate. So this is the OR symbol. So this concatenate symbol, what it does is, the operator, what it does is, it'll take your numbers and it'll combine it into a concatenated and make it a single number. So 1, 5 and 6 can be operated with the concatenate operator, and it will become 156. So now I think we get more results which are correct. 156, 7290 and 192. 192, 156, 7290. These three things should also be possible. Shouldn't be very hard. I'll have to change the code a little bit, but let's try it. Okay, so in the next part, I've not made much of the changes here. Everything is pretty much the same, except here I've moved. We were checking this inside the if, but instead of checking and putting the value of the result in this flag. If it's true, then we can just return it, and if it's false, then it will check for any other possible operators. In this one we were doing addition. Here we're doing concatenation, which is basically combining the numbers into one single number by converting it into a string. That is like one easy way that I could think of. So it's doing that, and it's finally returning the result. Why we're returning the result inside the loop itself is, after you've checked this, it's sure to finish the entire operand's length inside this, so we can just return it here. Okay, oops, check for the output. This is very slow. Okay, let's see if this gives us the right answer. Great. All right, we're done here. So I think I can further improve the efficiency by using dynamic programming. Probably that will help. Everything in recursion, usually there are chances of it repeating. So if we stop the repetition by checking what state we are currently at, and if that state has been visited, then the efficiency improves. But it is not too slow, so that's a plus. But anyway, I will see if I can improve this before pushing the code to GitHub. Alright then, see you in the next one. Bye bye.